Hi, this is Millie K, and it's Wednesday, July 10th, 2019. And in this video, I provide a sort of virtual tour of the Headworks structure at the Oroville Dam Spillway in Butte County, California, USA. I made a video in 2017 about Are the Gates Safe? And at this time, I want to take a closer look at the Gatehouse structure and point out some details I may not have covered in the previous video. I'll be showing photos from DWR's galleries and a clip from DWR's YouTube channel, a video clip. And any information that I read or graphics that I show are from the DWR's California State Water Project Bulletin number 200 from November 1974. And in this video, I'll use the term Headworks and Gatehouse interchangeably. And you'll see that in documentation that it's referred to in various ways. And this engineering drawing shows the gates at the top, and then here is a drawing of the structure. This shows the upper deck, the maintenance deck across the top here, and then the gate bays are down here. And this drawing is from a perspective of as if you're in the reservoir looking downstream. And you can see the 8 gate bays are numbered on these drawings. So looking downstream, gate number 1 is to the right here, and then consecutively numbered 1 through 8. And the radial gates are also shown here. Really, I'm not going to enlarge this. It's a very blurry sketch anyway, because even the original is. And so really what you can see here are, just to get an idea of how the gates work, you can see the radial gates here and here. And so you would have the hoist deck is up here, and these gates are hoisted into an open position. And then when they come back down, they come down with their own weight, and they rest on the sill plate of the gate structure here. And I'll be showing you actual photos of gates, but I just wanted to show you that. And then let's go to the photos. This photo has been taken on April 3rd, 2019, and it shows the main spillway releasing water from the gates for the first time since May of 2017. And the releases shown here are about 20,000 cubic feet per second. So this was the first run of the newly reconstructed spillway. And this photo is a good view to see the dam over here at elevation 922 feet. And as you continue on and you reach the gate structure, the top of the structure is also at 922 feet elevation. So here's the gatehouse structure here. And then you can't really see it, but if you're on the dam and you come down a ways and follow the road, there's a bridge road that goes over the spillway, and I'll be showing you that. So that gives you a good overview. Now, this is a photo of the original construction. And this photo was taken in 1967. And the State Water Project Bulletin says that the structure was founded on competent rock and sliding was not considered a factor in stability. So there you can see all the construction going on. And next is a photo from January of this year, 2019. And I chose this as a good overview of the Gatehouse structure's features. In the foreground, you can see the emergency spillway. And as we zoom in closer, you can see the various decks. So you can see the whole structure here. And it's 570 feet across. And at the top is the maintenance deck, and it's 21 feet wide. And then as I said, it sits at an elevation of 922 feet, just like the dam itself. Because if you're coming off of the Dam Crest Road and you just kept going, it would lead to that deck. And then below it is the Hoist Deck right here. And that one is at an elevation of 886.5 feet. And I'll show you better photos of that as we go along. And below the Hoist Deck is that road that when you come off of the dam, and you would come around and follow the road, and it becomes the bridge road over the spillway. And that road sits at an elevation of 870 feet. And below the road is the Trunnion Deck. And this Trunnion Deck is where the Radial Gate joints are anchored to the concrete piers. And in this photo, you will see some support jacks or columns in these areas. And some people say that those were put there to support the Spillway Bridge Road during the construction because so much traffic went over that road. And others say that they were put there to shore up a sagging gatehouse. And I just want to point out that the columns are not part of the original design, so you won't be seeing them in most of the photos that I show you. And then below there is the gate bays that allow the passage of water down the spillway when the gates are open. And there's 8 of them, 8 openings, but you can't see them all in this photo. And speaking of gates, there aren't a lot of really clear photos of the gates at the Oroville Spillway. So what I'm going to show you are radial gates at the diversion dam about 4.5 miles below the gates here. And it's about 4.5 miles below this spillway. And they are of a different size, but they're good as an example of a tainter gate. That's also the name, the tainter gate or radial gate. And I'll show you the photo. This photo is from 1966, and it's at the diversion dam. And if you look, well, there's 14 gates here, and they're not the same size as the ones at the Oroville Spillway, but they're shorter and wider. But this gives you a good idea of what a radial gate looks like. And you can see these gates are all up. They've been hoisted up. Here's the hoist deck for that dam. So they've been put in the up position, all except for one of them. This gate is in the down position. You can see it's got the flat arm. So you've got, these are the trunnion joints here. So the way uh, their trunnion decks are more like this. And if you note that this gate that's closed, this section is dry. And this photo's from 1966, so these were brand new at the time. So that gives you an idea of what a radial gate is. And just like I showed you in that drawing, then they use their own weight. They're weigh between 20 and 30 tons, so the very weight of them helps them to go back down. And then the next photo, this is a really good photo to zero in on. It was taken on February 23rd of 2017, and that was not long after the spillway incident. And as a matter of fact, they were starting to reduce the outflows on this day from 60,000 cubic feet per second. I think it got down to about 50,000 that day. They were needing to remove the debris from the diversion pool at the bottom of the spillway. So they were actually reducing the flows on that day. And then let's look at that hoist deck. This is a good view of the hoist deck. And I'll read this from the bulletin. The flood control outlet radial gates are operated by electric motor-powered cable drum hoists located on the hoist deck. The gates may be operated locally or remotely from the Oroville Area Control Center. Normal power for hoist operation is supplied through a buried distribution line from Edward Hyatt Station Service Power System. Standby power is available locally in the form of a 55 kilowatt generator operated by a liquid propane gas-fueled engine. Normal power supply is sufficient to operate all gates simultaneously. And there's 2 of these for each gate. And you can see here the passageways for them to get around on the hoist deck. And then here's the Trunnion Deck, and this is a close-up of the Trunnion Deck. And the releases averaged about 60,000 cubic feet per second on this day, too. This was February 18th, 2017. So it had been like about a week after the spillway incident, and they were trying to get the lake level down. I don't know if I called this the hoist deck. This is the Trunnion Deck. And you can see the, if I make this big enough, this is the Trunnion Joint, and then where they're anchored to the piers. And I cover this a lot in my previous video about are the gates safe. So you can see the arms of the radial gates here and the trunnions. And these are where the rods that anchor the gates into those piers. That's what that is. Now, this is a picture of the gates. And I'll read this from the bulletin. Reinforced concrete piers 5 feet thick separate the gated water passages. The piers also support the breastwall and service decks and provide anchorage for the gate trunnions. The pier noses are steel armored to reduce wear, and guides for stop logs are welded to the leading edges, which actually that's explaining the next photo. I'm going to go back and read this. I got ahead of myself. I just wanted to show you these gates, the front, looking directly at the gates from the spillway. The gates are 33.5 feet high and about 17.7 feet wide. And what we're seeing here are gates 2, 3, 4, and 5. And we know that because the middle pier is double and there's 4 gates on each side. So you can't see gate number 1 in this photo. And this is what I wanted to read. This is March 27th, and the gates are closed, and the lake level was about 838 feet, so there was about 25 feet of water behind the gates. And from the bulletin, as the radial gates are submerged, rubber seals are required on all 4 sides of the gate. The bottom seal is a rubber bar mounted in the sill plate. The gate rests on the bar, and its weight affects a tight closure. The side and top seals are hydraulically actuated, double stem rubber seals. Hydrostatic pressure is applied behind the seals by a direct connection to the reservoir with a 2-way activated valve to relieve internal pressure when moving the gate. The side seals slide on and seal against embedded steel plates in the walls. Because sliding occurs when gates are opened or closed, the seal noses are Teflon clad. The friction factor assumed between the Teflon clad seals and the stainless steel plates was 0.1. So now I'll go to this photo. This photo, the lake level was very low because they were doing construction. So it was like about 785, and you can't see it here. And they've opened, 1, 2, 3, gate number 4 and 5 have been opened for deliveries and also for ventilation. And from the bulletin, reinforced concrete piers 5 feet thick separate the gated water passages. The piers also support the breast wall and service decks and provide anchorage for the gate trunnions. The pier noses are steel armored to reduce wear, and guides for stop logs are welded to the leading edges. I'll show you the guides for the stop logs in another photo, but these are the steel armored pier noses. And next, I like this photo. However, I read that the lake level, on the picture it said the lake level is 812.6, and I verified that with the CDEC data, but the bottom of the sill for the gates is 813.6. So it says it's at a level of 812. It looks to me like it's all the way up there, but I don't know. I'm not going to worry about it. But the bottom sill of the gates is at 813.6. And you can see the top maintenance deck here at an elevation of 922 feet. And then over here is where the emergency weir comes in. And it, the top of it is 901 feet elevation. And then in March of 2017, they sent divers down to work on the gate seals. They needed to reduce seepage onto the damaged spillway. And in this photo, the lake level was 845 feet. So they're at the inlet to the gates. And with a lake level of 845, that means there would have been 30 feet of water on the gates. And in this photo, you can see where those stop logs go. Those are the grooves for the stop logs. I'll read to you about the stop logs. A set of stop logs is provided to dewater outlet bays to allow maintenance work to be performed on the radial gates. 5 interchangeable leaves are stacked in slots in the pier noses and make up the set required to close off one gate bay, so they each have a set. The gate leaves are each 8 feet 10 inches high and were constructed of half-inch thick skin plate and box-shaped ribs. Rubber seals are used on all 4 sides, J seals on the top and sides, and wedge-shaped seals on the base. Each leaf is provided with a 4-inch gate valve to refill the volume between the radial gate and stop log and thus equalize the pressure for gate removal. The stop log leaves were designed for a hydrostatic head of 87 feet. That goes, from elevation 813 to 900. And the bottom stop log seal was modified after initial use. A softer rubber bar type seal was used to completely seal the bottom corners. Also, a modified slide gate with regular ropes as operators was installed on the bottom stop log to hasten the filling time of the space between the stop logs and the radial gates. Okay, the next photo. This is where they're boring holes. This is May of 2018. They're boring holes to put explosives in so that they can break up the original concrete slab of that upper spillway. And they have these steel storage containers to make a protective wall to shield the gates during the blasting. And I have a DWR video clip of the blasting. It's pretty short. So I'm going to go here. Okay, so now we'll go back to the photos. The next 2 photos I chose just to explain about this inlet channel. This first one was in July of 2017. And the lake was at 797 feet, and it so you can't really see it. And this is looking toward the reservoir from one of the gate passages. And then this other picture was actually earlier. That was in May of 2017, when the lake was at 830 feet. And I'm showing both of these just to demonstrate that the lake has to be at a certain level before opening the gates, because activity in that area, if you look at what this is made out of, this inlet channel, activity in that area with the water drawing through could create erosion, or more specifically, scouring of the inlet. And I had heard in a press briefing back when the spillway incident happened that it needed to be at about 830 feet. So if that was correct, then this would be about the level that's needed in order to prevent the scouring. And I'm going to leave you with this photo. This is a night view, and it's from April 2nd of this year, 2019. And the releases that day were about 20,000 cubic feet per second. And just like one of the first shots that I showed you at the beginning of this video, it was the first time that they had used the spillway since May of 2017. So this was the first time they used the newly reconstructed spillway. And I want to thank you for viewing my video, and I hope that you will like, subscribe, and share it. And whether you're new or existing subscriber, if you ring that notification bell, you can choose to be notified of new videos or other communications. And if I have or find additional information about the gates, the gatehouse structure, or anything pertaining to this subject of this video, I'll post it in the description box below this video. So thanks again, and I'll see you later.